Welcome to the Insightful Professor. Today we're going to discuss what a view in a relational database is. So in this section, what we'll talk about is providing an explanation of what a view is, discussing how to define a view in a database. We'll also demonstrate how a view can be used within a query. And then finally, we'll explain how the view is actually stored, or more appropriately, say, remembered by the database system. Before we get into a view, let's take and ask another question. What is a table? Well, a table is a collection of named columns in unordered rows. So in the real world, we have these things that we'll call entities, and each entity can be represented by a table. So a table is a representation of some kind of an entity type. For example, we might have departments, we might have employees, we might have vehicles, and depending upon whatever the application domain is, we can have a number of different things. But to represent these things within a database, we use a table. So we would have a department table, an employee table, a vehicle table, where each row would correspond to one instance of the entity type. So for the employee table, we would have one row corresponding to the employee named Mo, another separate row corresponding to the employee named Curly, and so forth. Each column within the table would correspond to an attribute or property or characteristic of an entity. And then we say that each column also is going to be assigned a name when the table is created, and also designated as being associated with or holding data of a particular type. So for example, we could say that a column is going to hold numeric data. It's going to hold date-time data, or it will hold character data. And we specify that type when the table is created. Now, from these statements, we see that a table then is a representation of something of interest to us that exists in what we'll call the real world. That is the application domain that is of interest to us. Now, following that up is what the whole video is about. What is a view? To answer this question, what we can do is say that the same statements that we expressed to describe a table could also apply to a view. That is, a view, for all practical purposes, is going to behave or look to us much like a table. So then, what's the difference between a table and a view? Well, they're not exactly the same thing, so they're not just two different names for the same thing. It turns out that a table might be considered real in that it exists in some physical space. It consumes some storage within the computer. The representation of those rows takes up some storage space, some disk space. But when we have a view is often considered a virtual table. What this means is that its data or its content is obtained by accessing, kind of transparent to the user, some other object. It's obtained from some real tables when we access the view. So the view actually doesn't store data, but when we query the view, it gets data that's stored in some real table. I'm sure that does nothing to help you understand what a view is, but the point is I want to convince you that tables and views are not the same thing. Now, the view itself has no storage. That's what we said a moment ago. So therefore, it can't store any data. A view is somehow going to be associated with a table, a base table, a real table. That's where the virtual nature of the view comes into play. So how does this virtual thing actually work? Well, we can think of a view as what I call a stored query. Now, let me give you an idea of how that works. Take this SQL select statement here, this query. What we're doing is selecting several columns from the course table and selecting those columns only for those rows where this condition or predicate is evaluated as true. So we'll select the course number, the name, the description, the credit, and the lab fee for all those courses where the sponsoring department is CIS. That is, for all those courses where the C department has a value equal to CIS. Well, what happens if we run that query in the database? Well, we get a subset of rows and subset of columns from the course table. But how would you describe that result? Well, whenever you run a query, the result that's produced takes the form of a table. So we call that a result table. Now, the data that comes back that, say, populates this result table comes from the course table, because that's the table name we specified in our from clause. So this query accesses that table, the course table, and of course it's accessing its stored data and returns some of that data in our result table. Okay, that table is what we might consider to be virtual. Why would we consider that to be virtual? Well, suppose right now there are 6 rows that satisfy this condition of C department equal to CIS. But we run this same query tomorrow, next week, next month, and all of a sudden 8 rows are returned because CIS has started to offer additional courses. So now the structure of the result table would be exactly the same, but the content of that result table would change based upon the data that currently exists within the course table within the database. So it'll always reflect what's going on in the database. So it's the same structure, but its content will be subject to change based upon what currently exists within a database. Now, this is where the view comes in. Suppose we wanted to run that query very often. Rather than enter the entire query each time we wanted to do that, we would perform a data definition operation whereby we would create a view and associate this view name with the query. And that's exactly what we're doing right here. We're saying create this thing called VCIS, and it will be this query here. Remember, this query, if we were to run it, produces a result set that would be subject to change each time we run the query, a virtual result set, a virtual table. What we're doing is saying, whatever this table looks like, we're associating the name of VCIS with this table. Now, what's neat is when we run this statement to create the view, it does not execute the query, it simply remembers it. Let me make this a little easier to understand by going into my database. So here, what I'm going to do is run the original query that we discussed. Select course number, course name, course description, credit, and lab fee from the course table, but retrieve only those rows that satisfy the condition of C department being equal to CIS. And we get these 5 columns. There are actually 6 columns in the table. We retrieved only 5, and we retrieved only 6 rows. Those rows that satisfied the condition of C department equal to CIS. Let me just remind you what we have in this table, if you haven't watched one of the videos in a while. Let's select everything from the course table and observe that there are 14 rows in the table, 6 columns. So what we did was we selected a subset of rows and columns. Now, notice the condition that we expressed was C department equal to CIS. Currently, in this table, there are 6 rows for which that condition will evaluate to true. Those are the exact 6 rows that we saw in our result table. But if tomorrow there was a 7th row, what would happen is when we run the query we ran up above, 7 rows would be retrieved. And again, that's the virtual element that we're talking about. Let's take this query here and go ahead and create the view that we were describing. We would say create view. I'll give it a name of VCIS. I'll associate it with this query. And now, notice it didn't run the query, but it does tell us that this object was created, the view was created, because create view is a data definition statement. So what now happens is this statement is remembered by the system. And here's where the real exciting stuff comes in. I can say, let's select everything from VCIS. That's the name of the view. And notice what it actually did was take this query that is associated with the name of the view, and when I select from the view, it actually executes that query for me. That's pretty wild. We also could treat VCIS just like a regular table by saying, well, maybe I don't want everything that VCIS has to offer me. I'll select the name of the course, the lab fee of the course, the description of the course, again, being just some of these columns. I'll select this from VCIS, and I'll reduce the result set so that it focuses only on the rows where the lab fee is greater than 0. So now I selected a further subset of the rows in the course table. We can think of it as being a subset of these rows here, the rows that describe the result set for VCIS, the virtual table. So we can use a view just like a regular table. We use it in the from clause, and we can select some of the rows, some of the columns. We can do many other things with a view, just like a regular table. So that's the idea on how the view is created. Now, you might not see an immediate benefit because all we're really doing is reducing the query to something different. Ultimately, we're going against the course table behind the scenes. Now, the reason this could be beneficial is when we look at security, we could say, well, I don't want you to be able to directly query the course table. That is, you cannot run a select against the course table yourself. I deny you the privilege to do that or permission to do that. However, I can create this view which basically controls what kind of query will be executed against the course table. Right? That's what we were doing here. And I could give you permission to access the view. This is where a view can enhance security in the database. A view can do another important thing. The query we're illustrating here is not all that complex because it involves only a single table. But very often in practice, a view will be defined against multiple tables. That is, it's a multi-table operation for the query. Select from the course table and join it with the class table and join that with the registration table. So we could join multiple tables. Suddenly that becomes a complex query. But we can shield a user from the complexity of such a query by creating a view and associating that view name with that complex query. Then the user simply runs a simple query against the view, but behind the scenes, the complex query that is associated with the view is what is actually executed. So I'm sure you're curious as to where this view definition is stored. Well, in Oracle, it's stored in something called all views. In DB2 and SQL Server, it's stored also in the system catalog. All views is part of Oracle's system catalog, which it calls the data dictionary. So every database is going to store this. Say every relational database will store the definition of the view, that is the stored query, in the system catalog. And let me just show you how you could retrieve that. If this is going to work against Oracle, you would have to change the query for DB2, for SQL Server, for other databases. But the concept is the same. So here, notice I have a view whose name is VCIS, and look at the text in this thing called all view. That's the query that we associated with the name of VCIS. So this is part of the database's metadata. The stored query is actually accessible to us if we know where to look. Very neat capability. So that's a very quick overview of a view or virtual table. And I've gone through the slide here already and this slide. So let's summarize what we've done. We've provided an introduction to the concept of a view or virtual table. We discussed how a view can be defined within a relational database, and we demonstrated how a view can be used inside of a query. That is, it becomes the target of the query rather than going directly against a real table. We also discussed how a view is stored, or say remembered, within a database, because technically it's a stored query, and that query is stored as metadata within the system catalog. And that summary applies to Oracle, DB2, SQL Server, and so on. I illustrated the concept using Oracle, but the concept is essentially universal. Well, hopefully you found the video interesting, and if you found it useful, give me a thumbs up and offer some comments if you have some, and also consider subscribing to the channel. And once again, thanks for watching.